This project has been delivered in two versions: a development mode designed for testing and understanding the workflow, and a fully Dockerized production mode designed for scalability, persistence, and secure deployment. Dockerization means that the entire system runs inside containers, each service isolated but connected together. With Traefik managing secure access and PostgreSQL databases running instantly inside their own containers, the system is fully self-contained. Whenever the system is stopped or restarted, all services come back online automatically with the same configuration and data, without any extra setup.
In conclusion, while this system performs data extraction at its core, it is much more than a simple scraper. It is a secure, stable, and production-ready platform, built for long-term reliability and easy future improvements.
The Metabase platform is attached to a dedicated subdomain of the site. Metabase connects directly to the PostgreSQL database and allows users to create tables, reports, and interactive charts from the collected data, all accessible through a simple and intuitive interface. The platform is delivered through Traefik, which acts as a secure reverse proxy. All access is protected with HTTPS using automatically managed SSL certificates, ensuring encrypted and reliable connections at all times. Metabase is capable of creating a wide variety of visualizations, from simple tables and bar charts to pie charts, maps, and complex comparisons. Everything is configurable directly from the interface, making data exploration easy and interactive. The platform also delivers data through a secure API. Access is available only via the /API-matrix endpoint, protected by Traefik with SSL encryption and authentication. This ensures that data is delivered safely and reliably to external applications. In this moment, all services are running: databases, orchestrator, scheduler, API, Metabase, and Traefik. Now, we stop the entire system with a single command. All containers are shut down. Now, the entire system is stopped. As we can see, Metabase and the API are no longer accessible. The pages no longer load because all services have been shut down. Now, we will start the system again, and all services will come back online, fully functional. The entire platform is configured to restart automatically in case of a server reboot, which makes it powerful and reliable without requiring any manual intervention. As you can see in the video, Metabase takes a bit longer to restart, usually around 10 to 15 seconds. This is normal, since it is a larger service compared to the others. Once it loads, the platform is fully functional again. At every restart, the system automatically reads the .env file. This file defines the schedules for the scrapers, as well as the credentials and configurations for each service. The databases can also be initialized from here when the system is first built. If we want to completely reset the data, we can remove the old databases and rebuild them. Otherwise, all existing data and schedules are preserved automatically. One of the most common commands is checking the scheduler to verify if it is set correctly. The frequency of the scrapers can be changed easily in the .env file. For example, instead of 7, you can set 1, 3, or 20, which means the data extractors will run every 1 day, 3 days, or 20 days. This makes adjusting the schedule very simple without touching the code or rebuilding the system. There is a set of useful commands included in the project documentation, and many others are standard Docker commands. For anything that is not clear, You can always reach out to me and I will explain every detail step by step. In addition, I will prepare a short video with the most common commands for daily use. For example, how to change the Traefik password, how to modify the scheduler, how to check the logs, or how to run a scraper manually. All these operations are also documented inside the project, so they are always accessible. Right now, the extractor is scheduled to run automatically every 7 days, but we can also start it manually with a single command. When triggered, the program runs fully. It writes new data into the database, cleans up old or temporary files, and updates both Metabase and the API automatically. This is the same process that happens when the scheduler runs it on schedule. The only difference is that now we are executing it manually for demonstration. The orchestrator container includes all required dependencies, such as Playwright and Chromium, but it executes the local runner.py, which iterates through all scraper programs in the shared folder. Extracted data is written into the PostgreSQL database, visualized in Metabase, and delivered through the API via Traefik. This design allows us to add or modify scrapers directly in the project folder, without rebuilding the Docker image, making the system flexible, independent, and easy to extend. All services are Dockerized, with their dependencies installed inside the containers. However, the scrapers, the database, writing, and the cleanup logic are all simple files from the project folder. This means we can modify existing extractors or add new ones instantly, without rebuilding any Docker image, making the system extremely flexible and easy to extend. Metabase has its own dedicated database, completely separate from the scraper's database. This separation makes it possible, for example, to reset the extracted data while keeping Metabase users and dashboards, or the other way around. In both cases, changes can be made easily without affecting the other part of the system. In conclusion, the entire platform is fully Dockerized, with each service isolated but seamlessly connected into a single system. This architecture is highly scalable and allows rapid modifications without impacting functionality. Even direct file changes are applied instantly. It is a professional, production-grade approach, ensuring both stability and flexibility for future growth. After extracting the data, the system automatically processes it through a set of programs. Products are organized into types, categories, and subcategories. Temporary files are cleaned up. No file older than 7 days is kept, and the most recent result is always preserved for verification. At the same time, the data is written directly into the PostgreSQL database, and both Metabase and the API instantly display the new results. This makes it a true end-to-end production system, fully Dockerized, self-starting, automated, and reliable. So, in the end, we have a fully automated data extractor, programmable, production-ready, and completely Dockerized. Thank you for watching. Many people believe that $30 per hour is a high rate. I would like to remind that this project required around 40 hours of work and was billed for 33 hours. Hourly rates are only indicative. The real value lies in the expertise, efficiency, and results delivered. In practice, work is not charged with a stopwatch, but estimated fairly based on the complexity and outcome of the project. I offer a 90-day guarantee for everything I have built. If the scrapers need small adjustments or fixes, I can apply them quickly, because the system is designed to be very easy to modify. Usually it takes 1 to 2 hours, and in the rare case of a full rebuild, no more than 4 hours of work.